Hi, everybody. How's it going?
Hello, good. How about yourself, Miss?
Oh, I'm great, Ramon. I'm glad you could make it. So I'm super excited to do this. I haven't done this particular workshop before, but I've done a lot of tutoring before. I've just never done this free one before. So I'm really excited. I think you're going to get a lot of value out of it. So some quick things. I think most of you guys already did this, but if you could mute your mic so we don't hear any background noise, that'd be great. And if you have any questions, put them in the chat box. And then at the end, I'll save time for questions. But today we're going to cover one competency for math, right? And talk about tips and strategies and some practice questions. So I think you're going to love it. So some of you guys already know me, and my name is Courtney. And I've passed the core subjects and a bunch of other tests, but some of you guys don't know me, so I thought I'd introduce myself. I've been tutoring for since 2014 for lots of different Texas exams, and I've taken 14 of them, passed them all on my first try. So I love to take these tests and then tutor for them. So if you need help with a different test besides the core subjects, I can also help you with that. So before we start, I'd like to show you, and I bet you guys have already seen this because you're studying and it's a free resource, the Texas NESINC manual, right? I always like to start off there because it's free. It's usually not enough for most people to pass the test, but we want to go to it and check it out, see what we're talking about for tonight. So if we go to core subjects EC through 6, you can see the overview and exam framework for the whole test, right? But today we're just talking about math. So for math, you have 40 questions, an hour and 10 minutes, right? So less than 2 minutes per question. Some of them will be pretty quick and easy to get through, but some of them might take you a little bit longer than 2 minutes. So you have to budget your time, right? So definitely recommend you look through all of the information in this manual, especially the practice questions, because they're very similar to the questions on the real test. So that's a really good resource. So before we get started, I want to know who's excited to start teaching or who's already teaching. Put it in the chat box, please. I want to hear from you guys. All right, some people are teaching 4th grade, kinder. Bailey's super pumped, and I know Bailey well because we work together in tutoring. And Maria, I know her from tutoring also. I am so glad. So why do you guys want to teach? I know I wanted to make a difference and, of course, have a good schedule, right? But I'd love to hear why you guys want to teach. I think it's important for us to keep that in mind as we're studying for these tests. Give my students education. I wish I had that is beautiful. Yes. Some of us didn't have the best experience, right? Some of you are teaching social studies. Prepare the kids who will take care of us one day. Beautiful. Love working with children. Love the schedule as well. Yes. And now they're actually paying teachers a much better salary, which is nice, right? Like one of my clients was making $70,000 a year with her stipend, um, working with special needs students. Absolutely. So I want to show you, this is the data from the state, the TEA website that you can pull up, and it's the passing rate for the different tests, right? So we can look at core subjects, and they also have the old versions of the core subjects from years ago because this data goes back to 2017. But if we look at the most recent year, 2021 to 2022, and we look at math, the 902 is the new test, 78% passing rate. So that's not a terrible passing rate. It's higher than some of the other exams, but it's lower than most of the other core subjects like ELAR is 83%, right? So I consistently hear from people that fail the math and the social studies sections, right? Is that any of you guys, if you don't mind sharing? Math and social studies, is that kind of been a pain for y'all? Let's see. Just math. Yeah, just math. Yeah, for a lot of people, it's math and social studies, but yeah, and sometimes the other ones too, fine arts. It happens. I've seen it all, but math and social studies have the highest rates of failure, and I think these numbers are actually higher than the actual average for this reason. These are what's called finishers. These are people that are already teaching. So if we looked at everybody that's not teaching yet, I think these rates would be even lower. That's what I think. But that being said, let's get started so we can actually start our learning. And I'll show you from my course, we'll be going through Competency 3, which is on patterns in algebra. I thought this was a great one to start with today because most people need help with patterns in algebra. You'll notice I explain it in a very simple way and build on it, right? So you can see my course has all the competencies. It's super important when you pick a study guide that it's aligned to the competencies. Otherwise, it's not going to help you, right? So everything I do is aligned to the competencies. So every competency has a video, but I want to walk you through it instead of just showing you a video. So we'll talk about this today. So the first part of Competency 3 says show functions and relations by using concrete models, graphs, tables, symbolic and verbal representations, including real-world applications. So now we have to figure out, what does that actually mean? So what is a function? A function is just a fancy word for a relationship between a set of inputs and the corresponding outputs, right? We can think of it as a machine with the input coming in and the output resulting. So only one output per input, right? It'll make more sense as we go along. A variable, we know, is a symbol like X or Y that represents an unknown value. And this is how you represent a function. They call it f of x equals. So for example, if we have f of x equals x divided by 3, each input, x, has only one output, x divided by 3. That means it's a function, right? So now we need to talk about concrete models of functions. One way we could do this is a fun way. Who's ever made snowflakes out of papers before? Have you guys done that before, where you cut them? Yeah. Yeah, that's a fun way to do it. And another thing you can do, maybe it's not really snowflakes, but if you fold a piece of paper and then you make one cut at, at the edge, right? It's going to open up with different holes, right? And that's a fun way to do it. So what you can do is show students to fold paper, some in half, some in fourths, etc. And then they cut a hole in the middle of each paper along the folded side. And when they unfold it, then they record how many holes are in it. So if they cut it in halves, two pieces, not cut it, fold it. If they fold it in halves, there's only going to be one hole, right? If they fold it into fourths, there will be two holes, and so on. So this is an example of a function, right? The number of pieces and the number of holes that they're going to get, all right? Next, after making the chart, here's our chart, they can notice a pattern, right? Well, we notice that for y is 1/2 of x, right? 1 is 1/2 of 2, 2 is 1/2 of 4, 4 is 1/2 of 8, 8 is 1/2 of 16. So y equals 1/2 times x, right? So this one's a very simple linear function. Y equals 1/2 x, we can tell that y is only 1/2 of x, right? And then we could graph it, right? With a simple graph going up 1 over 1, up 1 over 1. I'm sorry, up, not up 1 over 1, we're going up 1 over 2, right? Up 1 over 2 because it's of the function. It's up 1 and over 2. So then you would discuss the function as a class and give a verbal explanation. So see how you're doing multiple parts. First, we're just saying what a function is, then a real hands-on activity, and then a chart, and then a graph. So that was a linear function, but let's talk about linear functions in more detail. For each change in x, the y is always the same. The change in y divided by the x is always constant. That's called slope. Slope is also called m. That's the variable used for slope. It's the change in y over the change in x. You might see it written delta y divided by delta x. Linear functions can never have exponents. If a function has an exponent, the slope is not constant, right? So to give students a real world example, you could tell them they can use this function to figure out how many video games they can earn if their grandma will buy them 2 video games for each hour of yard work they do. In this case, x is the number of hours of work they do, and y is the number of video games they would earn. So that makes it something they can relate to. Now they have an understanding of how this function can be used, show them how to figure out if the function is linear or not. Y equals 2x, right? That's our function. 2 video games for each hour of work they do, right? To determine that this is a linear function, we can graph it or we can make a table to check if the slope is the same, if the change in y divided by the change in x is the same. To make a table, fill out one column with the x values and one with the y values, right? We know y equals 2x. We already figured that out, right? Y equals 2x. So now we're just filling in the values. If x is 1, then y equals 2 times 1, or y equals 2. So we write x is 1, y is 2. If x is 2, it's y equals 2x, right? So 2 times 2 is 4. X is 2, y is 4. And then you keep going. X is 3, y is 6, and so on. Notice the change in x is always 1, right? 2 minus 1, 3 minus 2, 4 minus 3. And the change in y is always 2. 4 minus 2, 6 minus 4, 8 minus 6. So that means the slope is always the same. The change in y divided by the change in x is always the same. Another way you could do this is you could graph the coordinates and see if it makes a straight line. So if we graph these, going over 1 up 2, right? Over 2 up 4, and do all of those points, right? X is the value on the x-axis and y is up and down on the y-axis. So we're just graphing those. We can see it makes a linear function, right? Concrete models of a linear function. A teacher can give students manipulatives or counters where x is blue and y is green. They can use the counters to represent the function y equals 2x, that function we were talking about. If they have one blue counter, then they know they need twice as many green counters, right? So they will need 2 green counters. Similarly, they can use 2 blue counters, and from that function, they know they need 4 green counters. That'll help it make it more tangible. Next, we'll evaluate another function. Y equals x squared plus x. So what do we already know about this? Did we know if it's linear or not linear? It's not linear, right? Because it has an exponent. That little number up there is called an exponent. So it's not linear. It can't be, right? So if x is 1, then y equals 1 squared plus 1. All we're doing is plugging in the x there. Or y equals 2. Right? So x is 1, y is 2. If x equals 2, then y equals 2 squared plus 2, right? So that would be 4 plus 2, or 6, right? And then 3, we would do the same thing. If x is 3, we would do 3 squared plus 1. So 3 squared would be 9 plus plus 3 is 12, right? 3 squared plus 3. So 9 plus 3 is 12. So that's how we would graph that, and you keep going. If any of this isn't making sense to you, then I encourage you to watch some Khan Academy videos to supplement this. Or if you get my course, I explain it every competency And then you could keep watching that until it makes sense. But Khan Academy has some really good videos that are free. Notice that the change in X is always the same, but the change in Y is not always the same. Since the slope is not always the same, this is not a linear function. See how it kind of curves up? It's not a straight line, right? So that's not a linear function. We should also model our thinking out loud, kind of like what I'm doing when I'm reasoning through it. And that shows them our metacognitive strategies, thinking about our own thinking. Okay, next, talking about algebraic reasoning and concepts, right? So algebraic thinking is not just for algebra class, right? It's not just for middle school and high school. Even beginning and kindergarten students use algebraic reasoning to determine what will come next in a pattern and to make a generalization about simple math problems. They can also use manipulatives to make models to help them predict what number they need to add to get to a certain sum. The same manipulatives can be used to check their answer and be sure it is correct. Kindergarten students should be able to count by tens up to 100 and notice the pattern involved in counting by tens. If you don't really know what's expected at each level, then read the TEKS. If you just Google TEKS, it'll come up and then you'll kind of learn what's expected at each grade level.
Kaylee, y'all go in there for me. I'm doing.
Okay, so next, in first grade, students should use algebraic reasoning to perform addition and subtraction. For example, a teacher could ask the students how much they need to add to 2 in order to get 4. So 2 plus what equals 4, right? That's algebraic thinking. They should be allowed to use manipulatives to figure out the answer because remember that little kids can't think abstractly yet. They need manipulatives, right? So then they have a concrete representation and then a symbolic representation too, which is a chart. Is it required for the test to know the TEKS? Kind of, because they very often ask what's an appropriate learning skill for this grade level, or they'll give you a scenario and say, what grade would this be done in? So you do pretty much need to know. You don't need to memorize them, but you need to know what's expected at the different grade levels. You'll learn a lot of that in my course too. I talk about that in the course. Then the teacher instructs them to continue adding 2 to each new sum, and together they make a chart. 2 plus 2 equals 4, 4 plus 2 equals 6, 6 plus 2 equals 8, and so on. You're welcome. And then as students get older, they will use more advanced algebraic reasoning. Right by 4th grade, students should be able to use an input-output table to create a number pattern that follows a given rule. That's also from the TEKS. For example, using the data for the function y equals 2x, students will begin to notice that they are doubling x to get the y value. They should be able to predict what y is if they know the value of x. When students are struggling, teachers can encourage them to draw a picture or use manipulatives to show the results of the function. Teachers can make this more relevant to students by explaining that they can use this formula to double a recipe. And I've even seen teachers bring in ingredients to make something in class, right? And like one teacher I know, she brought in crock pots to the class and they made applesauce together and they used math to follow the recipe. So you could double the recipe. In this case, X would be the value of ingredients in the original recipe and Y would give them the new amounts needed to double the recipe. So see, this would be the ingredients for the original recipe. Y equals 2x. So if it's 1 egg, of course, then it's 2 eggs and so on, right? 1/2 cup milk, 1 cup of milk. To check the results, they could divide and make sure that they're getting the original number, divide by 2, right? Next, we have implicit and explicit rules. Implicit rules are implied or understood but not specifically defined. Explicit rules are clearly defined. For example, students counting by 5s likely understand the implicit rule of adding 5 to get to the next number in the sequence, but are not likely to be thinking of a specific equation or function. An explicit rule of counting by 5s would be y equals 5x, right? So this is y equals 5x because 1 is 5, x is 1. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So that's the explicit rule. The implicit rule is adding by 5s. Students can describe adding 5 to the previous number to give a verbal explanation of the rules and can also create a graph. So they could graph this. Patterns. So we need to know how to use patterns using concrete models, figures, numbers, and algebraic expressions. As previously mentioned, kindergarten students use patterns and predict what will come next in a pattern. They can use manipulatives to have a concrete model to help them determine what shape or color comes next in a pattern. In second grade, students are expected to recognize patterns in number families to help them continue to develop their understanding of addition and subtraction. For example, they will notice that 5 plus 6 equals 11 and 6 plus 5 equals 11, and also that 11 minus 6 equals 5 and 11 minus 5 equals 6. Those are called number families. Older students will also notice patterns in given sets of data and can determine the equation or function associated with that pattern or data. They need to be able to use the function to extend the pattern by graphing it or continuing the data in the chart by doing the next steps in the chart. We're doing really well, guys. I know it's math can be kind of boring and challenging, but look, we're already about a third of the way through the competency. So it's going really well. All right, next we have use properties, graphs, linear and nonlinear functions, and applications of relations and functions to evaluate, model, and solve problems in mathematical and real-world situations. So students can use number properties, commutative, associative, distributive properties to figure out mathematical problems and real-world scenarios. For example, if a student needs to add two numbers, he or she should know the numbers can be added in either order, right? That's called the commutative property. We can move the numbers and get the same answer.
Just better cold.
So this is mentioned in a different part of my course. So I've already reviewed this previously. So if you don't know commutative, associative, distributive, you would learn it in my course in a different part, right? Function is a relation between a set of inputs and corresponding outputs, which we talked about, right? And we already talked about a variable. Concrete models of functions, we talked about this too. There's a lot of repeats in the course, and then in the manual, and then I repeat it. So we already talked about this, right? And graphing it. Using variables and unknowns. So understand problem-solving situations and know how to translate them into expressions and equations using variables and unknowns. There are many different types of problem-solving situations that students can evaluate and use equations and expressions with variables to solve. For example, let's say a sixth grader wants to go on a field trip and he needs $100. He mows lawns to earn money. He charges $20 to mow, and each time he mows, he spends $2 in gas. How many yards does he have to mow in order to have enough money to go on the field trip? In this case, a student can make an equation or they can guess and check, right? First, we will show the equation. So if the student needs $100 and he earns 20 times when he mows and spends $2 in gas each time, we know he only really makes $18 in profit, right? $20 minus his costs, $18. So we need to use some algebra here. 18 times something. How many lawns does he have to mow to get to 100? 18 times x, right? Then we're going to isolate x by dividing each side by 18, right? So 18x divided by 18. Let me annotate this. So here we would divide by 18. That should be an 18, right? And then divide this side by 18. And then we have x equals 5.55. Now on the real test, I would have to do the math like this, right? I'd have to do 18 into 100 because you don't get a calculator on the test, right? But I'm not going to have you guys watch me do division and bore you with that. So let me clear my drawings here. All right. So that's how you would solve for that. And that's a real world problem where they're figuring out how much. If let's say you struggle with setting up equations and that way doesn't make sense to you, you could also guess and check. You could just say, okay, well, maybe if I mow 3 lawns, 18 times 3 is 56. That's not enough. And then I say, well, what if I did 5 and that's not enough either? And then I get to 6 and it's a little bit more. Well, I know that they have to mow 6 because you can't mow 5.55 lawns, right? So it has to be 6 lawns. No, you've never been allowed to use calculators on the core subjects EC through 6. It's never been allowed. On the 4 through 8 you can, but this workshop's for the EC through 6. Proportional reasoning. Luckily, they don't give you super advanced math. It's all stuff addition, subtraction, multiplication, division. There is some algebra, but it's all stuff. They're not going to give you like, 5-digit multiplication or something like that. Know how to model and solve problems, including problems with proportional reasoning, using concrete, numeric, tabular, graphic, and algebraic methods, using ratios and percents with fractions and decimals. So proportions, ratios, and percentages are taught in 6th grade, but the skills needed for proportional reasoning are taught before that, like fractions and decimals. Teachers can explain proportions in real-world terms to help students understand. So, for example, a 6th grade class is reading a novel for English language arts that is 200 pages long. The students have been complaining about how long it is, and it is taking them to read the assigned chapters. The math teacher tells each student at a time how long it takes him to read 10 pages. Each student must use proportions to figure out how long it will take him or her to read the entire book based on the data she collected or he collected. So, for example, Tim reads 10 pages in 20 minutes. How long will it take him to read the whole book? So we would set it up like this: 10 pages over 20 minutes equals 200 pages, right? The same unit has to be on the top, has to match in X minutes. Then we can cross multiply to solve, right? 20 times 200 equals 10x. Another way we could do this, that's a little bit faster, we could say, well, I know 10 times 20 is 200. 20 times 20 is 400, right? So if that doesn't make sense, let me show you how you would do it. Cross multiply, right? 10x equals 200 times 20, right? So here, to do 200 times 20, all I need to do is put my 4. 2 times 2 is 4, and 3 zeros, right? And then I'm left with 10x equals 4,000. Then all I have to do is divide each side by 10, right? And when you divide by 10, all you have to do is cross out 1 0. So I'm left with x equals 400. So it would take him 400 minutes to read the whole novel, right? So that'll help him budget his time. So that's a real world way to use math and figure out how long your homework's going to take you, right? So here's the math worked out also, but I did it live. So it will take him 400 minutes to read the novel. Next, we have linear functions representing data. To determine which linear function best represents a set of data, you need to use the data and check it against those functions. For example, if this is your data set, right, x is 0, y is 1, x is 1, y is 2, and so on. Here are 4 functions given. You must determine which function represents the set of data above. Y equals 2x, y equals x minus 1, y equals x squared, y equals x plus 1. First, let's fill in the data for function 1 to see if the data corresponds to it. Y equals 2x. 1 equals 2 times 0, right? Because we have y equals 2x, so y is 1 and x is 0. We can already tell this one's not correct because 1 does not equal 0. So that one doesn't work. So we can eliminate 1. Next, we have y equals x minus 1. So here we look at the values here. Y is 1 equals x minus 1, right? This is also false, right? So this function can't work. Y equals 2 and x is 1 minus 1, 0. That can't work. Next, we have y equals x squared. So if we look at the chart, y equals 1, 0 equals 0. Y equals 0 squared, 1 equals 0 squared, no. So we already know it's 4, right? It has to be 4, but let's look at it. Y equals x plus 1. So 1 equals 0 plus 1? Yes. 2 equals 1 plus 1? Yes. 3 equals 2 plus 1. So that one works. And so that one's correct. Next, we have relationships. So we need to know about variables, expressions, equalities, inequalities, and systems to evaluate, model, and solve problems. So inequalities are when you have a greater or less than sign, right? Y is greater than 3x plus 2, y is less than x squared. Teachers can give students real-world scenarios to make inequalities more relevant and interesting. Bob is a 6th grade student that is technologically savvy. His neighbors hire him to fix their computers and pay him $8 per hour. He is saving for the latest PlayStation and needs to earn at least $400 to buy the gaming system and equipment he wants. How can an inequality show him how many hours he needs to work to earn at least $400? First, go over what we know. He needs to earn at least $400 to buy what he wants. He makes $8 per hour. How many hours does he need to work to make at least $400? He needs to multiply 8, the amount of money he makes per hour, by the number of hours, and then set that up to be greater than or equal to $400, the minimum amount of money he needs for his gaming system. So it has to look like this. 8x is greater than or equal to 400, right? Because he's making $8 by an hour. We don't know how many hours he has to work to make at least $400, so it has to be greater than. Then we divide each side by 8, and 400 divided by 8 is 50. So he has to work at least 50 hours to make enough money to have that. To check his answer, he can multiply 8 by 50, which is 400, so he knows he did it correctly. Next, we have systems of equations, and we're almost done with this, and then we'll do some sample questions. First, right here, when you have 2 or more equations with variables, you can solve for variables. For example, x plus 2y equals -8, negative x minus y equals 9. First, isolate one of the variables in the first equation, right? So here we need to get x by itself. So we could do that by subtracting 2y, right? X equals -8 minus 2y. So we got the x by itself. That's our first goal. Next, we plug that into the second equation. So we know x equals -8 minus 2y. So I'm going to put that in parentheses here and keep the negative because it's negative here. -8 minus 2y minus y equals 9. These two negatives become a positive 8. This negative and that negative become positive 2y. Then we still have the negative y right there equals 9. So then we combine like terms. 8 plus 2y minus y is 8 plus y equals 9. Y equals 9 minus 8. Subtract 8 on each side. Y equals 1, right? So we know y equals 1. Now all we have to do is figure out what x is. So now we're going to plug 1 into one of these equations. We can do either one. Next, plug the value of y into either equation. Negative x minus 1 equals 9. Negative x equals 10. All we have to do to know what x is just change the sign because we're not looking for negative x. We're looking for positive x. Multiply by a negative on each side. X equals -10. Now we check our answer by plugging in the values of x and y into each equation. Y equals 1, x equals -10. That was our original equation, one of them. X plus 2y equals -8. So we need to plug in the value right here. -10 for x plus 2 times 1 for y equals -8. That's correct. We would do the same thing here and get the same answer. So it's always good to double check your answer by doing guess and check strategies. Very important to make sure you're on the right track. And then this is our last little section, and then we'll do some questions. Use algebraic methods to show an understanding of whole numbers using all 4 operations: addition, subtraction, multiplication, division, right? So you know how to solve for variables using all operations. 4 plus x equals 6. So then all we have to do here is take away the 4, right? So -4 minus 4, right? So x equals 6 minus 4, x equals 2. Here, if we have 4x times x squared equals 32, we're going to multiply the x times the x squared, and that gets x cubed. When you multiply exponents, what you do is you add them. 1 plus 2, so it's 3. That's how you multiply exponents. 4x cubed equals 32. We're going to divide each side by 4. X cubed equals 8. So then anything cubed is x times x times x, right? That's what x cubed is. So something cubed equals 8. Well, we know 2 cubed, 2 times 2 times 2 is 8. If you don't know the cube root of 8, if you don't have that memorized, you just guess and check. It's not 1, right? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8, and we already taught it, right? Be sure you know how to simplify terms and factor polynomials. So we'll talk about that too. Simplifying terms would just be like this. 2x plus 5x plus 7 is 7x plus 7. We're just adding the x's, right? Now, if this one was 5x squared, we couldn't do that. You can't add a 2x and a 5x squared because those aren't like terms. Now, if we're doing this right here, 10x times 5xy cubed, we're going to multiply 10x times 5x and we'll get 50x squared because x times x is x squared, right? And then we still have the y cubed. Factoring polynomials. Finding numbers and variables that divide evenly out of the polynomial. Examples of factoring polynomials. This is probably one of the more challenging parts of core subjects. If we have 5x squared minus 3x minus 2, we have to factor this. One way to do it is, okay, let me show you. We have to do the FOIL method. First, outside, inside, last, and they have to equal this, right? So this times this has to equal that 5x squared, right? So 5x times x has to equal 5x squared. And it does. And then this times this is 5 minus 5x. And then we do the inside plus 2x. And then the last is 2 times negative 1 minus 2. And then if we combine these, right, we're left with 5x squared. Negative 5x plus 2x is negative 3x, so minus 3x minus 2. So that's how you check it to make sure that it's factored right. It's the FOIL method. It's called FOIL. First, outside, inside, last. So first, outside, inside, last, right? And then if you struggle with factoring polynomials, Khan Academy has some good videos on factoring polynomials. But luckily, there's not a lot of questions on the core subjects about factoring polynomials. Remember what you learned in algebra. Please excuse my dear Aunt Sally, or some people nowadays say PEMDAS, right? First you do parentheses, then exponents, then multiply, divide, add, subtract. That's the order. You have to follow the order of operations. When simplifying equations, do whatever is in the parentheses first, then do the exponents, then multiply, divide, add, and subtract, right? So if we have 5 minus 2 cubed minus 6 divided by 2, first we do what's in the parentheses. 5 minus 2 is 3, and then leave the cubed, minus, and then do the division here, and because that's also in parentheses, right? Then we're going to cube this. 3 times 3 times 3 is 27, minus 3 is 24. And then there's more practice on order of operations if you're rusty on that on math.com. Which of the following equations is represented by this graph? So we can see that the y-intercept is 0, right? That's where it crosses the y-axis, is 0. And then the slope is rise over run. Remember, slope is rise over run. So if we look at this, if we go up 6 over 2, the slope is 3. So the correct answer is y equals 3x, because the y-intercept is 0 and the slope is up 6 over 2, which is 3. We could also do it by the graph if that way doesn't make sense to you. So what we would do here is we look at our x values and our y values, right? And we know the x-intercept is where it crosses the y-axis. So it's at 0, 0, right? And our equation for this is y equals mx plus b. That's our equation. B is the y-intercept. So we already know b is 0. But we don't know m. Whoops, that's not supposed to be in. We don't know m yet. M is slope. And slope, remember we talked about that at the beginning, is rise over run. Change in y over change in x. That should be a triangle. That's slope. So all we have to do is pick 2 points. Let's pick this point and this point, okay? So change in y would be 3 minus 0, right? This is a change in y, 3 minus 0. divided by the change in x, 1 minus 0. So the slope is 3 divided by 1. So now I know what my m is. My m is 3. Y equals 3x. So see how I got the correct answer by graphing, looking at the graph, and I also got the correct answer by looking at the table and then doing the math. So you can do it either way. All right. And then that's what I was just doing. So I worked that out for you live. So we already did that. If this stuff doesn't make sense, you can watch Khan Academy videos on slope and get caught up to speed on slope. But now let's do some sample questions and see how you guys do on this. So I'll let you guys put in the chat box what you think it is. And this is stuff that we've talked about today, but some of it is stuff that, like in my course, I would have told you to read over the TEKS by now. So some of it is going to be related to that too. Like you might not remember the kindergarten stuff yet, but let's see if you guys get this right. So I see D. So let me show you what happens in the course when you pick your answer. D is correct because it is the most learner-centered way for students to use algebraic reasoning. So when you're picking the correct answer, and you guys got this one right, which is great, we first want to pick one that's on topic. Which one is appropriate for kindergarten, right? So first, it has to be appropriate for kindergarten. Then it needs to be thorough. Which one thoroughly addresses the question? Then we pick the one that's most learner-centered, which is really important because it says that in the question, but that's the order for all questions. So that one we got right. Solve for x in this system of equations. So we did one like this tonight. First, we had to isolate x. Remember where we had to get x by itself and then plug in the value. So let's see if you guys can do that. Okay, so let's see if you got this one right. B, good job. B is right. So if you don't know how to do that one, does anybody need to work that one out? Yes, okay. So what I'm gonna do here, well, let me actually do this because it's gonna explain it and then I think this will be easier. All right, so first, add 2 on each side, okay? So y minus 2 equals 6, so we're gonna add 2 here, y equals 8, right? Plug in the y value, 8, into the first equation, x plus 3 equals 8. X plus 3 equals 8. Then subtract 3 from each side, x equals 5. Oh, no problem. So that's how you do
Courtney.
that. Yes.
Excuse me, which one do you suggest us to start with?
What time? I'm sorry?
No, sorry, which one, the one on the top or the bottom? Which
Well,
one is
whichever one
easy
is
to tackle?
easiest. So this one's really easy to just get y by itself, right? Because we're just adding 2. But you could do it y minus 3 equals x. but this is the easiest way.
Because it has only one variable.
Um, because we can just take this and then plug
Mhm.
it into y right there, so it's super easy.
Okay.
But you could do x plus 3. Let me do my annotating right here. So y equals x plus 3, right? So we could do x plus 3, which is this whole thing right here, right? And plug that in to y minus 2 equals 6, right? So it's just a little bit more steps. X plus 3 minus 2 is the same as x plus 1 equals 6. Then we subtract 1, subtract 1. So it's just a little bit more steps that way, but you'll get the same answer either way. So whichever way looks easiest to you, then that's what you want to do. There's really no right or wrong way. It's just what works for you. And then also you want to be thinking about what's fastest, right? Because your time is limited. But see in my course, if you get it right, or even if you get it wrong, maybe we'll get one wrong and then I'll show you how it'll just explain the answer to you if you get it wrong too. So now we have this one. So how would you set up this equation? This one's tricky. Good, right? They're trying to throw you off by saying dozens, but it's asking dozens of cupcakes, not how many cupcakes. Then you would pick B, but she makes $2.50 per dozen, right? So 250 times how many dozens would equal $120 that she needs to make. Good. Yes. B almost got me too, because I was thinking it was asking how many cupcakes she needs to sell, but it says how many dozens of cupcakes. So if it said how many cupcakes, then it would be B, right? And then C and D don't make sense. You guys are doing very well. Which of the following is a linear equation? So this one will be really easy if you remember what we talked about a little bit ago. C, good. Because it's the only one without an exponent, right? So you guys are getting that right. That's good. All right, now this one might be a little bit harder to do because it's a lot to read, but I'll scroll down when y'all are ready. And then we'll see what you guys think about this one. Good. He's noticing a pattern, right? The pattern of the days that it's watered and then making a generalization about it. So that one we have to kind of just understand what he's talking about there. So 5 is A, that's right. He's noticing a pattern of the days of the week and making a generalization about it, that it will never be watered on Tuesdays, Thursdays, or weekends. It's not formal operations thinking necessarily. It's not variables. And he's not in the sensory motor stage. That's for babies to 2 years old. And you guys are good. Yes, this one is also A. Let me show you how to do that. So we know that we want to know how many minutes she needs, right? And she needs at least this many minutes, so it has to be greater than. And she takes 3 minutes per question. And there's 30 questions. So she needs at least 90 minutes, right? X is greater than 90. So the correct answer is A. So this one, we didn't do one quite like this yet. I might need to show you how to do this one. So this one, let me see, number 7. You guys got it right, yes. So this one, what we're gonna do, because I think some people probably don't know how to do this. They're both y, right? So we can set them equal to each other. X squared equals x plus 12, right? Now what we're gonna do is get them all on one side and set them equal to 0. X squared minus x minus 12 equals 0. Then we're going to do what the FOIL method that we talked about earlier, where we're guessing and checking. We want to figure out what we're going to do to make this equal this. So we know we need something on the first one and something on the second one that both multiply to equal x squared. Well, I know x times x equals x squared, right? So x goes here and x goes there. Now, this number here and this number here have to multiply to be negative 12. So one has to be a negative and one has to be a positive. So it could be 6 and 2, it could be 4 and 3, right? So it could be 6 and 2, could be 4 and 3, could be 12 and 1. But here's the thing, they have to add or subtract to equal this number, right? I might be losing you here. If I'm losing you here, we can do private tutoring and really drill this in, or you can watch lots of Khan Academy. So we know that in order to get to 12, it could be any of those. But if we're going to add or subtract them, it needs to be 4 and 3 to get to negative 1, right? Because 3 minus 4 is negative 1. So we know that it has to be that. So the 4 needs to be negative x minus 4, and the 3 needs to be positive because negative 4 plus 3 is negative 1 to equal that. So I'll show you. X squared plus 3x minus 4x, the FOIL method that I was talking about, first, outside, inside, last, minus 12. See how that's the same as this, right? X squared minus x minus 12, right? So now what we'll do is we'll set these equal to 0. X minus 4 equals 0. And x plus 3 equals 0. So we know both of those are equal to 0. Right? So then we add 4 here. Add 4 here. So x equals 4. And subtract 3 here. X equals negative 3. So x equals 4 and x equals negative 3. Right? So I wanted to keep this to an hour and respect y'all's time because I know I think I even said 45 minutes, so I already ran over it a little bit. But did you guys learn something tonight? Oh, good, good. Well, I'm super excited. And I know that a lot of you guys already have study material for the core subjects, so you might not need anything, but if it's not working for you, because I consistently hear from people that have already bought a lot of stuff that is not working for them, right? And if you'll stay till the end, I have some free questions I'm going to give you a link for. But if your study material is overwhelming, or maybe it's a little bit more complicated than this, right? Then I want to encourage you to consider my course because I think I break it down in an easier way than a lot of the other programs, and it's quicker to get through. So you can see that in an hour, we got through a whole competency, right? Whereas some of the other programs out there might take you lots of hours for just one competency, right? Which maybe you need that, but a lot of people don't need to be spending hours and hours and hours on every single competency, because you've got to pass 5 subjects, right? So if you need a course, or if you really need a lot of help in math, I even have tutoring. So I have a couple of options. And some of you guys might need all subjects, so I'll show you that too. But I have a math only course that's great. And you get it for 3 whole months for only $39. So it's a great value. And it's like this, it's like what you saw, but it's gonna have all the competencies. So what we did tonight was just a little fraction. Or if you wanna meet me for tutoring, if you enjoyed this, I do this every Sunday night at 8 o'clock with a group. And we go through one competency each week. So tonight we're doing competency 2. And we'll go over it, and I send the recording the same night. So if you're interested in that, that's a great way if you're really struggling with math to get my help every week. And it's a great group. It's a small group, just 3 people tonight. So that's for the weekly tutoring and the course. So you don't have to pay for the course separately. It comes with the weekly tutoring. But if you only want the course, if that's not in your budget, or let's say you're real self-directed and you don't need the course, you don't need the tutoring, you just want the course and you'll do everything on your own, then you can do that too. Does anybody here need all subjects? Is anybody studying for the whole test? Yes. So I do have a bundle where you can save money. You can get all of the subjects, and they all have videos. They all have practice questions. It has everything you need. So this would be the cheapest way. So the bundle is for all subjects. So that's great. And that's for 3 whole months for $80, which is plenty of time for most people to study. Or you can pay by the month. If you're taking your test real soon, you can save money and just pay for 1 month. So I have it for every budget. Also, if you select Affirm or Klarna or Afterpay at checkout, it'll give you a payment plan. So you can, and some of them are even interest-free payment plans, which is a great deal. So, because I know money's tight when you're transitioning to a new career, right? So, so the math is only $39 for 3 months, or you can get all subjects $80 for 3 months. So it's a great deal. And I've heard from a lot of people that have tried. Oh, okay. Yeah, you did, Ramon. You have the tutoring. Oh, you didn't. You don't have the link for later today. It's in the same email that this link is in, but I can send it again. So yeah. So I'm excited for you guys. But lots of people have told me they've tried all the big name companies, and some of it's really good stuff, but it's overwhelming. And then some of it's just not super similar to the test, because the thing about these big companies is they have great marketing, right? And they have great software and everything. So they're not bad programs, but they make stuff for all the states. And I only make stuff for Texas. So that's why my stuff is really, it's really aligned to the test. And it's really just what you need to know, nothing extra. So yeah, so if you need a lot of help in math, then I would recommend the tutoring option, even though that's a little bit more money. You're going to get a lot of help. Yeah, if you just need math, I did put the link in the chat box for just the math course, but I'll put it again in case you need that. Let me find that. 1 second. So here's for the math only course and tests. Yeah, the other programs can be overwhelming. I've bought some of them. Yeah, I need to probably change it to a year. I've been thinking about that. I just haven't done it yet, so I didn't want to advertise that. But if you need it longer, I'm always very flexible about that. So don't worry about that if you need it longer. I do tutor for a lot of different subjects. For all of the core subjects, I do it for ESL, bilingual supplemental, BTLPT, LOTE, PPR. I can't even do special ed. I don't usually, but I can. I've passed the special ed. So almost any of the tests that you need, I can tutor for. And so I'll send you the link for my private tutoring. where if you need to meet privately, because the only groups I have right now is for math. I only have groups for math, and then I have a group for BTLPT and LOT, which are Spanish tests. But I haven't gotten enough people that want tutoring for like English language arts, social studies, all of that. So I don't have a group for those. I only have math right now. And I also only have so many nights in the week. I'm already doing group tutoring 3 nights a week and then private tutoring a couple nights a week. So some of it is, even if I had the people, I don't always have the time. But I love what I do. And I forgot to show you guys too, my testimonials, right? That some people have tried other programs, like I was saying, and then they use mine and they pass, right? For not just the core subjects, but for the PPR too, right? So some people have used it for the EC through 6 and other tests too, and say they can pass with ease. Highly recommend. She passed her ESL and ELAR 4 through 8 with my stuff. So lots of good strategies. Katie worked with me super hard. She had already taken it 3 times, and she had done some other programs, but her sister found me and asked me to work with her. And then we did some tutoring, and she passed on her next attempt. But I'm excited for you guys. Does anybody have any questions or comments or anything? Oh, and let me send you 1 second. I told you guys I'd give you some free questions. Let me pull that up real quick, because I don't want to forget that. I tend to forget, and I don't want to email it out because you guys, when I email, it's going to be everybody that signed up, but you guys actually came. So I want to give you some free questions for showing up. So 1 second, I'm going to be sending you a link for some free questions. Okay. So let me get back to the chat box 1 second. So this link, I won't email it out because this is only for you guys that came. So save this link, please. And then, yeah, it's exciting. I really think if you do my whole course, as long as you've got good reading comprehension, you know, then you're going to do very well on your tests. And I say that because, you know, if you don't have good reading comprehension, it doesn't matter which program you do, you're going to struggle, because until you get your reading comprehension fixed, that's going to be a struggle. But I want to thank you guys so much. I love what I do, love helping people pass. And yeah, the math is like I said, it's got the second highest failure rate. So you're not alone if you've struggled. But thank you guys so much, and I'll see some of y'all tonight, and I'll email the link again in case you didn't get it if you're enrolled in the tutoring. But thanks so much.